JavaScript benchmarking is a mess. I hate benchmarking code. Really? I have a little bit of like this weird kind of love for it, even though I know it's completely broken, especially like any form of micro benchmark. You know, that whole benchmarking language balls that is going around on Twitter. We already did a talk about that. We explained, Casey just mansplained to me why it's actually bad. But even beyond that, just there's several other things that are bad about it, blah, 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 blah. I love doing it. I just know that it's effectively worthless. It's effectively worthless until you do something that is like a large project, and then you actually try to figure out what to do inside of that. Then it's like then at least there's something better about it. Just like any human, which at this point most viewers of this probably aren't. It is much more fun to pretend that your caching of your value increased performance 1,000% rather than testing to see what it did. Classic. Just pretend like you know what you're doing. Alas, benchmarking in JavaScript is still necessary, especially as JavaScript is used when it shouldn't be in more performance-sensitive applications. Unfortunately, due to many of its core architectural decisions, JavaScript doesn't make benchmarking any easier. Not only that, but most people benchmark the wrong thing. You can actually get a shocking amount of good performance out of JavaScript by not benchmarking what the CPU is doing, but benchmarking where you're creating objects. The entire returning the default text response is so dumb. Yes, there's a lot of things that are dumb about the old JavaScript. Okay, what is wrong with JavaScript? The JIT compiler decreases accuracy. For those unfamiliar with the wizardry of modern scripting languages like JavaScript, their architecture can be pretty complex. Instead of running code through an interpreter that immediately spits out instructions, JavaScript engines utilize an architecture more similar to compiled languages like C. They integrate multiple tiers of compilers. There's also like a minimum amount of running. If you set on V8 trace flags, you'll see that like not all functions get compiled right away, and the length of the function determines if it gets compiled or not. And then there's certain levels in which it will do stuff, and it has this whole concept. It has this entire thing that it runs constantly about whether it should or should not do something. It's pretty wild. Each of these compilers offers a different trade-off between compilation time and runtime performance. By the way, this is also why you have a lot of memory usage when it comes to JavaScript. Like a lot of JavaScript's performance and memory usage comes from this exact thing. So the user doesn't need to spend. Oh, you know what I just realized? Chat, no one even told me. What the heck? Hey, say hi, everybody. Say hi. Everybody say hi. So the user doesn't need to spend compute optimizing code that is rarely ran, while taking advantage of the more advanced compiler's performance benefits for the code that is run most often. The hot paths. A lot of hot paths. Okay, guys, shut up. That's too much high. You guys are abusing your mod/VIP status. There are also other complications that arise when using optimizing compilers that involve fancy programming words like function monomorphism. That means just pass in one argument. That's all it really means, is that when you use a function, stop passing in the whole kit and caboodle as far as types go. Just pass in one type, and magically your function will be optimized quicker. That's all it means. But I will spare you and avoid talking about that here. By the way, this just goes to show how insane JavaScript is, that we have this as a term, and the reason why this term exists. Forgive my PHP, by the way. Forgive my PHP, but kid you not. That's because there exists functions, right? A sum that takes an x, and it's like if type of x equals, this, then we do that. And it's like that exists. Therefore, we can't compile that until we have some sort of idea of what's going on here, or we can't compile it well. We can't compile it to the maximal degree. Yes, that should not exist. That exists regularly. Okay, it just regularly exists. All right, so why does this matter for benchmarking? Well, as you might have guessed, because benchmarking is measuring the performance of code, the JIT compiler can have a pretty big influence. Smaller pieces of code, when benchmarked, can often see a 10 plus X performance improvements after full optimizations, introducing a lot of error into the results. For example, in your most basic benchmarking setup, don't use anything like the below for multiple reasons. Don't worry, we'll talk about console.time too. Okay, nice. Yeah, I don't know about console.time. I assume console.time is some sort of effectively date.now and then do it again and measure the difference betwixt them. Maybe it uses high resolution timers. I have no gosh darn idea what it goes on, but that's what I would assume go on. By the way, also, this is yet another reason why you should just benchmark big programs. If you're seeing a 10x different based on you warming it up or not, it just means that it's like not at all even useful. You're measuring just the wrong thing. You should just be measuring larger programs, or else it just sucks. All right, a lot of your code will be cached after a few trials, decreasing the time operation significantly. Benchmarking programs often do their best to eliminate caching and optimization, as it also makes programs tested later in the benchmarking process appear relatively faster. Again, this does not exist in larger benchmarks, right? If you can just go onto a production server, turn on flame graphs for a moment, that's going to be your true view, right? Like that's the actual view you're looking at. However, you must ultimately ask whether benchmarks without optimizations match performance in the real world. Sure, in certain cases, like infrequently accessed web pages, optimizations is unlikely. But in environments like servers where performance is most important, optimizations should be expected. If you are running a piece of code as middleware for thousands of requests a second, you better hope V8 is optimizing it. Yes, V8 should be optimizing it unless if you do something stupid. Again, trace ops, very, very good. So basically, even with one engine, there is two to four different ways to run your code with varying different levels of performance. Oh, also, it is incredibly difficult in certain cases to ensure certain optimizations levels are enabled. Have fun. Trace ops, very good. Very, very good. 01-03-01. It's very confusing. It's like 01-03- it might just compile, oh, your function's too long, you need a bunch more. So let's see. So just benchmark as part of your integration testing. Gotcha. This is why the only thing that should really exist is in production, you should just have week over week like response times from your API. They probably don't look like that. They probably look something like that, right? And you should just be measuring this, and then you should go, okay, what's going on here? Where's this peak at, right? Okay, where's the 99th percentile? How does this thing move? Because if you just look at this is the true benchmark, right? This is what's actually happening in production. If this changes and you see yourself having a right shift, then you know you done messed up. If you do something and you make it do a left shift, then you know you've done something good, right? And that's it. That's like where your benchmark should be. People that like when you see somebody do a benchmark that is, okay, hey, I have this function and it does this one thing, so I benchmarked it and made it the fastest as possible. Just know that you can take this in JavaScript and I want you to put it into the recycling bin, okay? And then I want you to empty the recycling bin and throw that crap away into the dumpster from whence it came, okay? Because this does not matter. This is not doing anything, okay? This is just you pretending like you're making a difference when you're not making any difference at all. You can not consider production to be completely fair. You can try to set up some sophisticated benchmarks that go on and really attempt to measure how well your app is performing. And you can do things like memory measurements and CPU measurements and all that. But at the end of the day, none of that's good. I hate to say this, but this is just a clear skill issue. It's not a clear skill issue. Micro benchmarks are a way for you to convince yourself that you're doing something without actually doing anything. Something premature optimization. So it's not this either. I actually really dislike that phrase premature optimization because most people don't even know what premature optimization means or really what the purpose of that statement was, which was don't write assembly when you can just write C first. Premature optimization is the root of all evil is a stupid thing for you to say. And here's why. Is people take that phrase and then proceed to write the worst program ever, being like, oh, I can just optimize it later. And sure, there will exist some part of your program that is just massively slow in this one tiny access. And this one you can just probably take out and make faster. But you make a bunch of really dumb decisions throughout your entire program over and over and over and over again to the point where you can't just point to one part of your program and say, this is slow. Every part of your program is slow. Every part of your program is a problem. The point of that phrase, by the way, was to not write assembly when you can just write C instead. Don't optimize your program to the level of assembly first write it in a language in which you can get almost all the performance out, and then attempt to over-optimize the really hot spots, and that's it. Premature optimization does not mean write bad code. It simply means write the best code you can, and then if you need to, you break out of the language you're in and go as low level as possible. All right, anyways, the example in the previous section will be inaccurate as it only measures by milliseconds. Now, switch to the performance.now. Great, now we have timestamps in microseconds. Yes, now you're just doing that. Fantastic. Okay, except, let's say they are all in increments of 100 microseconds. Now, let's add some headers to migrate the risk of timing attacks. Oops, we still can only do 5 microsecond increments. Okay, hold on, did I miss something? Okay, anyways, here we go. Engines, I did miss something. Okay, I did miss something. No wonder I was confused. Okay, engines do their best to stop you from timing accurately. You know fingerprinting, the technique that allowed do not track to be used to aid tracking? Yeah, JavaScript engines have been doing their best to migrate it or mitigate it. This effort, along with a move to prevent timing attacks, led to JavaScript engines intentionally making timing inaccurate, so hackers can't get precise measurements of the current computer's performance or how expensive a certain operation is. Unfortunately, this means without tweaking things, benchmarks have the same problem. Also, again, Doc, like this whole notion, what are you doing? What are you doing measuring JavaScript on the microsecond level? What are you doing? Stop it right now. That's crazy. Gosh darn it, you're not worried about microseconds, okay? You're not. You've never been worried about microseconds. If you're using JavaScript and the next thing out of your mouth is, I'm worried about microseconds, don't use JavaScript. Okay, it's just not the right choice. Okay, there's this whole phrase like use the right tool for the job, and oh man, it's really good to make the trade-off between performance and like familiarity with a tool, because one tool you can go really fast in and the other one you have to go really slow in. But if you keep talking about microseconds or nanoseconds and then you say JavaScript, I'm just gonna take you and do the Batman, just slap you. Stop it. Isn't it amazing how well Chrome V8 folks have done to make a language that no one would ever use for performance? Oh, dude, no, I've said this a cajillion times. People do not appreciate the V8 team enough, okay? What the V8 team did is absolutely incredible. For those that have no idea, a team at Google called V8 took a language called JavaScript and literally made it 100 times faster. And this is the reason why JavaScript exists the way it does, is because the work of like 12 engineers who somehow lifted the entire world onto their shoulders. They literally became Atlas and hoisted all of our internet experience onto their shoulders and made it fantastic. And now we have servers that run JavaScript because of their actions. I can't tell if they're the good guys or the bad guys. Which one is it? It's kind of like when you buy your wife Life cereal. She's going to eat the whole box, and maybe she doesn't want to have that available to her, but because you bought it trying to be nice, now she's going to eat a bunch of sugar and feel bad. Are you the good guy or the bad guy? Nobody knows. All right, the example of the previous section will be inaccurate as it only measures by milliseconds. Now, let's switch that out for performance.now. Great, now we have micro timestamps. I didn't realize they're only in increments of 100 microseconds. That's kind of crazy. Now let's make add some headers. What is let's make add some headers? Dude, that phrase is, I don't really know what they're saying. Reduce precision. To offer protection against timing attacks and fingerprinting, DOM high-res timestamp types are coarsened based on site isolation status. Resolution is isolated context. Oh, in non-isolated context, 100 microseconds. Oh, I didn't even know that. Even if you decide to run your code through the browser and let the compiler do its thing, clearly you will still have more headaches if you want to accurate timings. Oh yeah, and not all browsers are made equal. Yeah, that's a fact of life. Safari mentioned. Hey, Safari, why do you gotta be the way you are? The rest of us updated our life. Even Microsoft's edgelord, Bill Gates, made Edge better than you. How does that feel? How does it feel to be beaten by an edgelord? I love Bun for what it has done to push server-side JavaScript forward, but dang, it makes benchmarking JavaScript for servers a lot harder. A few years ago, the only server-side JavaScript environments people cared about were Node.js and Deno. I still like to call it Dino, okay? Both of which used V8 JavaScript engine, the same one in Chrome. But, by the way, isn't this hilarious whenever you see these benchmarks that show Dino and Node having two different performance profiles for some sort of JavaScript, and you're like, what? How did that, Porque Maria? How did that happen, right? So if you do like the whole, the language performance benchmarks thing that have been floating around Twitter, right? Have you seen this? Don't look at the one that right. Where is it? Where's the one? Someone give them to me. Look, there we go, right there. Do you see that? That thing, right there. We can just look at it. Why is Bun faster than Go? What's going on here? Can somebody please mansplain to me how any of this exists? Bun is Zig. No, Bun is not Zig. Fellas, Bun is a Zig runtime with JavaScript core, okay? When you're writing JavaScript, you're executing JavaScript, which underneath is executing JavaScript core, which is C++, okay? The benchmark isn't real, it can't hurt you. Well, it's in the room with me right now! When you say Bun is Zig, it's like yes, no. It depends on what you're running, right? Are you running the runtime? Then yes, you're running Zig, okay? Good. Okay, when you do set timeout is not a JavaScript thing. It doesn't execute in JavaScript land, okay? That's why things like Loveit, which is Lua's implementation of libuv, that's why libuv exists, is because set timeout has to be executed outside of the JavaScript engine. It's not inside of it, okay? That's not a thing. It's not there. It's not there. There's no there. I know that might blow your mind. I know a lot of people right now are completely shocked by the fact that when you do a set timeout, you're actually going into the runtime to set a timer to re-execute JavaScript again. It's just how it works, okay? Learn to love it. All right, but instead uses JavaScript core, the engine in Safari, which has an entirely different performance characteristics. It's not like entirely different. I mean, they're not that much different. They are different, but it's not like entirely different. Shook. This problem of multiple JavaScript environments with their own performance characteristics is relatively new in server-side JavaScript, but has plagued clients a long time. The three different commonly used JavaScript engines, V8, JSC, and SpiderMonkey for Chrome, Safari, and Firefox, respectively, all can perform significantly faster or slower on equivalent pieces of code. One example of these differences is tail call optimizations, TCO. TCO optimization functions that recurse at the end of their bodies like this. Kazam! Look at that beautiful piece of code. Look at that. Just look at it. Would you look at that factorial? Try benchmarking a kajillion in Bun, and now try the same thing in Node.js or Deno. You'd get, you should get an error similar to this one. Maximum call stack size exceeded. Oh, nice. In V8, and by extension, Node.js and Deno, each time the factorial call itself at the end, the engine creates an entirely new function context for the nested functions to run in, which eventually is limited by the call stack. But why doesn't it happen in Bun? JavaScript core that Bun uses implements TCO, which optimizes. Is this true? I think, doesn't V8 optimize? Does it not? I thought V8 did that by now. All right, well, hey, everybody, let's find out. I'm just going to go to personal. I'm going to go vim test.js, put that in there, go in here, factorio, all right, that's probably a little bit too long, but yeah, let's just find out. Node test.js. You're right. Okay, bun test.js. I deleted my computer last week, okay? That's where I'm at, okay? In V8, okay, so so V8 does do this. Okay, hold on, install bun, hold on. I know there's like hold on, shut up. That's pretty neat. I didn't realize that. I didn't realize that bun had TCO. I swear that V8 had TCO. Does it not have TCO? That kind of seems like an important thing to know. Chromium issue 4 million? Is that 4 million? Hold on, how big is that number? Chrome issue 40,600,000? Damn! Not updated yet. Description, tracking bug, tail calls, support for full code gen. Yeah. RIP. So it looks like there is some commits that are going on. This was, I guess this was in 2016. A lot of talk, a lot of jibba jabba in 2016. People are like, oh, we need to optimize tail calls. Still talking about, still yapping about it 3 years later. Still yapping about it. This issue is migrated right here. Okay. Got migrated a decade later, and page not found. Wrecked. Absolutely wrecked. All right. Well, that is great. Well, Here we are, everybody. Okay, well, I didn't realize that. I honestly just assume. I just always assume every language has TCO at this point because this just seems like an obvious. This just seems like an obvious W. Can we all agree? Migrated to GTFO. Yeah, they decided TCO is premature. Yeah. Not only does the above design avoid call stack limits, but it also is much faster because it doesn't require any new function context. Absolutely. There's a lot of things that have to happen when you create a new function. Like, have you ever thought about what it takes to execute a function? When you execute a function, you have to take your program counter and you have to point it to a new location. You're going to need to be able to return stuff back out, so you have to have some sort of memory region to like a return. What about arguments that go in? You're going to need like memory locations for arguments, so it can point to these different arguments that exist. You're then going to need to be able to run through this code, and if something returns, you have to be able to like walk it back up. So when you do something like 1 plus, re-recursing foo n-1 or whatever it was, like that was like summing. I guess we're adding how many times this thing exists. Like, remember, you have to keep on creating this so that each one returns from each location, and functions are not free. So if you can convert a function into a for loop, it's big time. Like, that's big time. Essentially, these differences just mean you should benchmark across all engines that you expect to run your code to ensure code that is fast is fast in one isn't slow in another. I just don't think you should do this. I'm gonna be real here. I think that most JavaScript issues do not exist in code this size. I know it does happen, but when it happens, it generally is because it's bad for everybody. Let's see. Essentially, these differences just mean you should benchmark across all engines that you expect to run your code to ensure code that is fast in one isn't slow in another. Also, if you are developing a library that you expect to be used across many platforms, make sure you include more esoteric engines like Hermes. They have drastically different performance characteristics. Yeah, they're also working on that whole static Hermes. That's kind of exciting. The garbage collector and its tendency to pause everything randomly. So this is like a huge thing that hasn't even honorable mentions. I would say this isn't an honorable mention. This is the reason why micro benchmarks suck, right? If you have a micro benchmark that simply that does like a for loop and say it does it 500,000 times, it does like a quick 500,000 times and it creates an object, you may not even ever get a garbage collection right here. But if this thing were to exist in production, this thing every single second would be taking up some amount of the time to be able to do the whole like copy and pasta, follow through, follow all the links and everything. So it's like it lies to you. It just lies. GC is a very important measurement that you're just being lied to. Okay? You're being lied. JIT compiler's ability to delete to all of your code because it isn't necessary. Terribly broad flame graphs in most JavaScript dev tools. I think you get the point. I don't really mind the flame graphs. I think they call them icicle charts. They're flame graphs, but I like their flame graphs. I think it's pretty good. Bun would never lie to me. No. Was Rust mentioned today? Several times. So what is the solution? I wish I could point to an NPM package that solves all of these problems, but there really isn't one. On the server, you have a slightly easier time. You can use D8 to manually control optimization levels, control the garbage collector, and get precise timings. Of course, you'll need some bash foo to set up a well-designed benchmark pipeline for this, as unfortunately D8 is not well integrated or integrated at all with Node.js. Yeah, I tried to set up D8 once and used that for a while. I got very confused with some of those things. You can also enable certain flags in Node.js to get similar results, but you will miss out on features like enabling specific optimization tiers. There you go. An example of D8 with specific combination tier Sparkplug enabled. D8 by default includes more control of GC and more debug info in general. I don't think you need to control GC. I think that is never something you should even have to think about. I think that if you have a GC problem in your code, it's because you're writing bad code. There you go. You can get some similar features on JavaScript Core. Honestly, I have not used JavaScript Core CLI much, and it's heavily underdocumented. You can enable specific tiers using their command line flags, but I am not sure how much debug information you can retrieve. Bun also includes some helpful benchmarking utilities, but they are limited similarly to Node.js. Unfortunately, all of this requires the base engine/test version of the engine, which can be quite hard to get. I have found that the simplest way to manage engines is ESVU paired with ES Host CLI, as they together make managing engines and running code across them considerably easier. Of course, there is still a lot of manual work required, and these tools just manage running code across different engines. You still have to write to benchmarking code yourself. I just don't think it's real. I honestly think you're making work for yourself. Everything he says, by the way, is true. Everything said in this blog so far has been absolutely true and amazing. I just think that you're just doing work for the sake of doing work. I don't think you're actually doing work that is needed for 99.99999999% of problems. There's like that one or two libraries that you actually should be benchmarking, and the rest you don't even need to do. If you're just trying to benchmark on an engine with default options as accurately as possible on the server, there are off-the-shelf node tools like Mitata that help improve timing accuracy and GC-related errors. And many of these tools, like Mitata, can also be used across many engines. Of course, you will still have to set up a pipeline like above. On the browser, everything is a lot more difficult. I don't know any solutions more precise timing and control of the engine is far more limited. The most information you can get related to runtime JavaScript performance in the browser will be from the Chrome DevTools, which offers basic flame graph and CPU slowdown simulation utilities. Yeah, I think a lot of this, in the browser, most of your problems are going to be not probably JavaScript. They're probably going to be related either to GC, which is like JavaScript adjacent, or it's going to be like you painting the screen 1,000 times. It's like, it's more you just doing something stupid more than anything else. And so what it always is. Hakuna Matata. Did you say Matata? I did. Matata. Conclusions. Many of the same design decisions that made JavaScript relatively performant and portable make benchmarking significantly more difficult than it is in other languages. All right? There are many more targets to each benchmark, and you have much less control at each target. You're asking me to pronounce JSON correctly? It's a JSON. Don't worry, French sardo. I already know how to do it. It's a JSON. Hopefully, the solution will someday simplify many of these problems. Here's the solution. Build your program, benchmark it in production, and when something is terribly slow, attempt to do a flame graph. You'll likely be surprised at where you proportionally spend your time, and benchmark the whole gosh dang thing in production. If you do it any other way, you are just sniffing your own farts. Okay, you're getting high off your own supply. You're out there just pretending you are the insurance companies making laws around insurance. Like, it's just like that bad, right? You're not doing anything but just benefiting yourself because you think you found something that's great. You're patting yourself on the back. Yay, we did something, and you did nothing, okay? I might eventually make a tool to simplify cross-engine and compilation tier benchmarking, but for now, creating a pipeline to solve all these problems takes quite a bit of work. Of course, it is important to remember these problems don't apply to everyone. If your code is only running in one environment, don't waste your time benchmarking other environments. Agreed. However, you choose to benchmark. I hope this article showed you some of the issues present in JavaScript benchmarking. Let me know if a tutorial on implementing some of these things I describe above will be helpful. I think that these are all great things. Like everything he said here is just fantastic. I just don't think it applies to most people. I think most people try to do this benchmarking and they don't do anything. It's kind of like someone that's just like, I'm going to benchmark React to make React a lot faster. It's just like you've already kind of chosen your tier of performance. Like if you wanted something faster, you'd have just chosen solid. It's different in kind. It's going to operate it operates inverted comparatively to React. And so therefore it's kind of like, well, what are you doing here? Right? If you're trying to get that much more performance, choose something that's better.
Kudos for at Nightshade Dude for great job here, heart.
Don't ever compliment the mods again. You understand me? Don't you ever compliment the mods again. The name is don't do that again.